All right, starting chapter 7, looking at measurement, estimating actual and scale distances. And when we're looking at maps, maps really just use ratios, like we were using in the last chapter, to take a real life distance and be able to get it to fit in a smaller space, like on a page or on a map sort of thing. So when we do these scales, this first part here, scale equals, this is going to come up over and over and over again. But it's going to be the distance on the map divided by the distance in real life. So this is really important that you know this, because this is going to be over and over and over again. But it's going to be the map to real life. That comes up over and over and over. So I'd get that written down, try to commit that to memory, at least keep it in front of you as you do the homework in this thing. So example 1 says, 10 miles in life is 1 inch on a map, write the scale. So we need to first then figure out, okay, so what's the distance on the map? And then we just divide that by the distance in real life. So on the map we have 1 inch, so then we'd have a 1 in the numerator there, divided by the distance in real life, which is going to be 10. So it's tempting maybe to say it's a 1 to 10 ratio, but technically it's not going to be that. It's going to be even bigger of a change than that, because it's 1 inch on a map over 10 miles. So if you have the same units, you don't have to put units in. If it's 1 inch on the map, is 10 inches in real life, you're fine. But if you have different units, you do need to write them in. Now we could write the ratio that way. Probably the more common way you'll see it is going to be 1 inch equals 10 miles. Or maybe 1 inch colon 10 mi. And by the way, you need to do mi for miles. Just a single lowercase m stands for meters. So mi for miles every time. All right, so now when you're doing the scale yourself, you're going to get some questions that says, figure out the scale here, or if this is true. Given the option, I would highly, highly, highly recommend using centimeters on the map. So cm goes in that blank there. Because if you're using fractions, you get like 1 3/8, 1 5/16. If you're doing centimeters, you can just do 2.7 or 1.4. It works a lot easier with the decimals as opposed to the fractions. All right, so this next one. On a map, you measure the distance to be 100 miles to be 5 centimeters long. So 5 centimeters on the map, 100 miles in real life. Estimate the scale. Okay, so if we go back to that thing that's at the top, it's the distance on the map over the distance in life. And it's not a bad idea to write those. You at least need to think that through. It's real common people just do, oh, it's 100 miles divided by 5 centimeters, because that's the order they're in. But this case is actually going to be the other way around. 5 centimeters on the map is 100 mi, or 100 miles. So now we could leave that as a scale, but that's not reduced. And if we're doing these ratios, we really do need to reduce it. So if I look at 5 and 100, those are both divisible by 5. So I'm going to take and divide by 5 and divide by 5. So if I divide them both by the same number, it still stays equal. So now I have 1 centimeter on the map is going to be 20 miles in real life. And that's going to be easier to picture because 1's a 1. So you could write it that way, or like we did above, the more common way probably is 1 centimeter equals 20 mi. That'd be another legitimate way to write it, or 1 centimeter colon 20 miles. That third way I'd say is probably the least common. All right, one last example and we are out of here. So a map has a scale of this. How far apart are 2 houses that are 3.75 inches apart on the map? All right. The first thing you do when you get a question like this, you'll notice you have 3 numbers, and 2 of the 3 numbers are going to be a scale. You're going to do tons of questions like this in this chapter, and essentially it does what we ended up doing at the end of the last chapter. It's a proportion. It's going to be a 1 ratio equals another ratio. So 4 numbers go in there, and one of our numbers is missing. If you have a scale in this chapter, really your first step pretty much every time is going to be to take your scale and put it right there. 1.5 inches over 20 miles. Now there's 2 ways to figure out where to put the 3.75 inches, because this is something that messes up a lot of people. Probably the better way is the numerator is the distance on the map over the distance in real life. So then you just have to ask yourself, the 3.75 inches, are we talking, where are they going to be on the map, two things that are 3.75 inches apart, in your bedroom or in the classroom or on the front lawn? Or is it 3.75 inches on the map? And in this case, they tell you it's 3.75 inches on the map. So 3.75 has to go here because the numerator are all going to be distances on the map. The denominator is all going to be distances in the real world. So 3.75 inches goes up here, and we're going to solve for an x down there. And when we find x, it's going to be a certain number of miles. The other way that can work, I'd mentioned like, hey, put in the units, it's helpful. Because if you have inches in the numerator, miles in the denominator, you don't even need to think about is it map or real life. If they give you something in inches, it'll go in the numerator because inches are in the numerator in this example. If they give you something in miles, you're going to have to put it in the denominator because miles are there. So the units in the numerator, units in the denominator always will be the same. All right, once we're here, we cross multiply. I'm going to do those two first because I like seeing x on the left side of my equation. So 1.5 times x equals these two. We can do that because we know those two fractions are equal. And usually I don't mess around with writing the units in at this point. Perhaps that's bad, but that's just confusing to a lot of people. But I could do 20 times 3.75. That'll give me 75. And then I say, all right, I want to get x by itself. That's the goal. Well, x was multiplied by 1.5, so we're going to divide by 1.5 to cancel that out. To keep it equal, I always have to do the same thing to both sides. So 75 divided by 1.5 then gives me 50. And we're almost done. That 50 is going to go right up in here. So if I were to put, looks like I can't erase it, but if I were to put my 50 right there, it's going to be 50 miles because it's in a denominator. So final answer, 50 miles. So there's our learning targets. We went over all that stuff here in the notes. You'll get that stuff in the homework. Let me know if you have questions of any of it. Just a comment quick in the notes. We have this part here, that those are going to be the ones where just look at the number. If it's closest to 0, so if it's between here but closer to 0, round to 0. If it's closer to 0.5, round to 0.5. If it's between these two, is it closer to 1, closer to 0.5? That's it for the section. Let me know if you have questions.